In this video, we are going to continue to solve the questions about finding the trigonometric ratios when one of the ratio is given. Here the ratio is not given, but angles are given, and you know the ratio of the 45 or sine 45 or cosine 45 from the table, and or by using your finger, or you know the values of 60, sine 60 or cosine 60 by using your fingers. So it's easy to find now for us. It's easy to find the value of x if you know the sine 45, cosine 45, and these values. Okay, here we have to know this one firstly. I'm going to name these sides like A and B, and here this side is also, it's going to be equal to A, and without using the Pythagorean theorem, by using sine or cosine, because sine 45 we know that it's equal to, if we count from the down 0, 1, 2, it's going to be 2 up, and the sine 45 is equal to root 2 over 2, and here it's equal to sine 45 opposite over, which is at the same time sine 45 in ABH triangle. Sine 45 is equal to A over 8 it's going to be, so sine 45 is going to be equal to, I made a mistake, A over 8 is going to be equal to root 2 over 2, so 2a is equal to 8 root 2, a is equal to 8 root 2 over 2 is going to be, so a is equal to 4 root 2. So if you know that the trigonometric ratio is given here and you found the value of a, but for finding the x we have to find also b, and here this is equal to 4, this is equal to 4, and we have another triangle here. Here the angles are 30, 60 and 90 degree. So here in this right triangle, sine 60 is, or we are going to say tangent 60 normally, tangent 60, because this is a over b, in tangent 60 is equal to sine 60 over cosine 60 it's going to be, and that's equal to root 3 over 2 over 1 over 2 it's going to be, and it's going to be equal to, as you know, it's going to be equal to root 3. Okay, this is tangent 60. Tangent 60 at the same time, tangent 60 in AHC triangle, tangent 60 is equal to 4 over b. 4 over b it's going to be, so 4 over b is equal to root 3 it's going to be. Here 4 is equal to b root 3, and 4 over root 3 is going to be equal to b. Of course we don't know, we don't like the denominator with root, so we should rationalize the denominator, so it's going to be equal to 4 root 3 over 3, that's equal to b. Okay, the x value is going to be equal to a plus b, then it's going to be equal to 4 root 2 plus 4 root 3 over 3 is going to be. Okay, the next question. Here again the one of the angle is given, one of the side is given, and we are going to find, by using the trigonometric ratios, we are going to find the perimeter in this question. Here this is isosceles trapezoid, and we know the properties in isosceles trapezoid. When I draw the line segments here, this one down, and which is altitude, here also which is altitude, I know that this is going to be this lengths, they are going to be same. Here, these lengths, they are going to be same firstly. Then this is 90 degree altitude, because this is 90 degree, this is 90 degree, this is 90 degree, it's going to be, and this length here, this length, it's going to be equal to also 4. Then if this is 4 and totally if it is equal to turn, then if I say this is x and this is x, x plus 4 plus x is going to be equal to 10, 2x is equal to 6, and x it's going to be equal to 3. Now I said this angle is going to be 90 because I draw the altitude, and here these two sides are parallel, that's why it should be 90 degree. Then if it is 90 degree, then this is going to be 120 minus 90, which is equal to 30 degree. And I know that here this is 3, this length is 3 here, and in the right triangle I need the hypotenuse for finding the perimeter, and if I say the perimeter hypotenuse is h in the triangle, in the, let's say this is h, ADH, in ADH, sine 30 is equal to 3 over h. And we know that sine 30 also it's equal to, sine 30 is equal to 1 over 2. So 3 over h, so 3 over h is going to be equal to 1 over 2. H times 1 is equal to 6. So h is equal to 6. Here, if this is equal to 6, then this is going to be same, and it's going to be equal to 6. So totally the perimeter is 4 plus 6 plus 10 plus 6, it's going to be, and it's equal to 10 plus 16. Perimeter is going to be equal to 26. Okay, for the last one, here this question a bit confusing, because we have to draw extra lines here. Here the tan alpha is given, but it is not in the right triangle, and they are asking find tangent alpha. Here the way for solving this one, half angle formulas. What I mean, here when I draw the line segment from the center, I know that this line segment, it's going to make 90 degree angle with the tangent point. If tangent point is 90 degree, at the same time here, and this is 90 degree, and this is going to be equal to 4. Pardon. This is going to be equal to 4, because this is also reduced and this is also reduced. And here this angle is also, it's going to be alpha, and this is going to be 2 alpha. And if this is 4 and totally if this is 5, then AT is AT square plus TO square is equal to AO square is going to be then AT square is equal to OA square is equal to 5 square, TO square is equal to 4 square. It's going to be AT square is equal to here 25 minus 16. AT square is equal to 9. AT is equal to 3 is going to be, so this length is also equal to 3. Now I have double angle here. I'm going to draw the right triangle here again, and it's going to be here. I'm going to draw the right triangle here, and we are going to solve by using the half angle formula, and I'm going to explain that one too. Here, if I move here, now I set the 2 alpha here. I'm going to say this is 2 alpha, and 2 alpha is going to be equal to the angle opposite of 2 alpha is 3, and here it's equal to 4, and this is equal to 5. And we have to find, ladies and gentlemen, we have to find tangent alpha. How we were finding the tangent alpha? By using the half angle form. We were expanding the form. We were expanding the form here, and we were completing as much as possible with the hypotenuse here. So this length is going to be also equal to 5. I'm going to make it 5 here, and this is going to be 5 here. Then I'm going to continue to make this one to one right triangle here, and here this is isosceles triangle, and in the isosceles triangle, here this angle and this angle, they are going to be equal to each other. That's why alpha plus alpha is going to be 2 alpha, if you remember. Now the length is here, it's equal to 5 and 4, totally it's equal to 9 is going to be here, and 9 here it's equal to 3. So the tangent alpha is going to be equal to 3 over 9, which is opposite of alpha over adjacent of alpha, and that's equal to 3 over 9, and that's going to be equal to 1 over 3.